Presentation will examine several causes of poor quality voice over IP or VoIP calls, and in fact, this would extend to applications such as video conferencing as well. But we'll examine 6 primary considerations, including your internet connection, latency, jitter, packet loss, the router you're using, and of course the overall network connection. Now, we'll get into each of these in greater detail, but any one or all of them can of course contribute to poor quality voice over IP calls. So, beginning with the internet connection itself, quite simply, voice over IP is considered to be a real-time communication application, which quite simply requires fast internet. It's not like watching a recorded video, for example. In this case, we have both parties wanting to communicate with each other, so that's what it means to be communicating in real time. So, quite simply, if your internet connection is not fast enough to support these types of applications, then really your only option is to consider upgrading that connection. Now, that's almost always an option. It's just likely going to cost more for that additional bandwidth. But if it's something that you need to conduct business, then it's certainly worth the investment. Now, latency refers to a delay. Now, there are a couple of different types of latency, including what's known as propagation delay, handling delay, and queuing delays, but all of them refer to a delay. The propagation delay is quite simply the amount of time it takes to travel from point A to point B. And even though we're dealing with communication speeds that are usually measured in only a few milliseconds, the longer the distance you have to travel, the longer the propagation delay will be. If, for example, you're making a voice over IP call halfway around the world, then those packets will quite simply take longer to get from point A to point B as compared to something like making a voice over IP call to another building in the same city, for example. The handling delay refers to all of the components that have to process those packets. So the routers, for example, that the packets travel through will all process those packets. So it takes a certain amount of time to get through each of those devices. And once again, the more devices there are between points A and B, the longer the handling delay will be. And queuing is typically an issue when there is a lot of congestion. If a router simply has too much traffic to handle at any given time, it will just queue packets that need to wait to be processed. So again, the busier the routers are, the more queuing delays you will encounter. So all 3 will of course add up. Now, you can mitigate this to a degree by implementing what's known as quality of service. This allows you to prioritize this type of traffic, but that's only something that you can configure within your network.